I've always envisioned the Pont Neuf when I do this problem, seeing one of the people standing on the bridge selling bottles of water for €1 to all the tourists as they walk around Paris. So I put it into a problem that says you're thinking about buying a bike to start a bottled water business, small business. The bike you want to buy is $1,400. Now, the reason that you're going to buy the bike is first in year one, you think you can earn $500. In year two, you think you can earn $650. And in year three, you can earn $700. Now, anytime we start transitioning from personal problems into corporate problems, we still incorporate this idea of a rate. These five variables that we've grown to love and rely on are still going to apply, but sometimes the words that we use are a little bit different. So, for example, when we use rate, we oftentimes like to use the economics term of opportunity cost of capital. And what that just suggests is that if you're the business owner in this case, you have $1,400 and you're expecting to be able to earn a rate of return on it. The way that you're thinking about earning a return is by buying this bike. But one of the beautiful things about finance is you always have freedom to choose. I don't have to start this bike business. I could start a different business. I could open a brasserie, or I could go ahead and start up my own small consulting firm, or I could just invest in the market. And so long as these things are of similarly risky investments, I apply that idea that the scarcity of the $1,400 requires then, if I invest in this bike, to get an alternative or opportunity cost of capital. In this case, we're suggesting 5%. So, oh, I have the answers here already. Let's go ahead and delete those so you can't see them. And now let's go ahead and get to it. All right, so I went ahead and I broke up this problem in a slightly different way. So I want to go back and bring in our process just so that we can keep it off to the side here, because I do still think there's some value to it. So we've gone ahead and documented all assumptions, etc. So now what we'd like to do is start to determine what is solved for. Whenever we come up with this idea that we need to make an investment decision, the most common thing we're solving for is going to be present value. Present value is going to be the easiest way for us to think about what could happen right now. Because notice we have 3 years. And in year one, what's being suggested is you would bring $500 in. There are no payments per se to think about, but a payment in this case would be something like, what if I could make $10 a day? $10 a day. A payment, whenever we deal with payment, is going to have the following components. A payment is always going to have a constant amount, and it's going to be in every period. Well, in this case, we have 3 periods, 1, 2, and 3, but the amounts aren't constant, so it's not a payment, but rather what we can do is we can do a present value calculation for each and every one of these, and then once they're in the present, we can just simply add them up. So how do we go ahead and solve for this? First one, if the rate is 5% and this first $500 comes in 1 year from now, first we'll do it again is we'll go to Formulas Financial, and we are determined that we are solving for present value. So let's go find our present value calculation over here, and then follow our inputs at a rate of 5% per year. When I have to wait 1 year, when I get no payments, and I expect 500, notice that the way that the formula returns to us is a negative. Again, the idea being here is I would be willing to make a cash flow out, also known as an investment, today of up to $476.19. If you give me $500 in 1 year, assuming I could earn 5% otherwise. It's bigger so we can see it all at once. This to me is the best way to really think about present value. Here's the maximum cash flow out. Would you be happy if it was only $1 that you had to pay to get 500 in a year? Well, of course. But would you give $550 today if you got $500 in the future? Well, not if you're expecting to earn 5%. So I really like thinking about it this way. All right, and then for the second one there, we're saying you're going to get a $650 future value. Again, no payment. The rate, again, is going to be 5% for us. This one's in 2 years. Let me show you a slightly different way to do this formula then. The navigation way will work and we'll do just fine, but I like to just type. If we look up here, you can see that these are just characters that are typed in. So how do we do that on our own? Well, equals is always a formula beginning. The name of the formula is PV, and it even tells you it's the PV returns the present value. If I open parentheses, it then says, well, what rate do you want to use? I can highlight my rate, comma, ask me for my number of periods. Note, the European version of this is often different. Instead of comma, you may have to hit semicolon. And again, if your version of Excel is in Indian or in French, you're going to have to translate and figure out what the names of the formulas are in Excel. I prefer if you worked in English, but of course I'm an American and biased that way. Okay, comma again, here's my payment, comma, here's my future value. And so what that suggests is for $650 that I would get in 2 years, if I have the chance to invest and earn 5% otherwise, I'd be willing to pay up to $589.57 today. All right, for the last one then, it looks like we're going to go ahead and have a $700 cash flow in with no payment. Our rate is staying at 5%, and our number of periods is now 3. Notice because we keep using this common structure of PV, FV, PMT, rate, and N per, that I can now just copy and paste this thing. And if I was to look at the formula structure, look at what it's pointing to, rate. E23, exactly. Number of periods, E24, perfect. Payment, E22, grand. And future value, E21. So I was able to copy and paste that so quickly because I had set these things up with the exact same structure. So we put this all together then, and the question that we're trying to ask then is what would be that net total cost that you would be willing to spend? So to get us to that net total cost, all we're going to do is then pretend like we would make these 3 investments right now. So let's do equals. Because they're all negatives, I'm going to go ahead and put a minus sign in front of it just to switch the end answer, open my parentheses, and then I can add these 3 amounts up. And I make my columns a little bit bigger. What that suggests to me is that I should be willing to pay up to $1,670 for a bicycle that allows me to go and sell bottled water, earning $500, then $650, then $700 over 3 years, assuming I could earn 1%. When we interpret then and compare that, we would compare that number to the bike's actual cost. And if you're standing there talking to the bike vendor and you're negotiating a price, in your mind, you now have a reservation price which says, I'd be willing to pay up to $1,670. And this person's only asking me for $1,400. So therefore, this seems like it would be a good purchase decision because this net total represents the maximum total, total amount I would be willing to pay today for the present value of those future cash flows. close at 5%.